Hello, in this video I'm going to be talking about this worksheet on scientific notation. Before I get started on that, I want to review a couple key ideas in scientific notation. Firstly, generally speaking, this is how scientific notation looks. We have a number, it's only got one digit to the left of the decimal point and then some other digits past the decimal point, and then it says times 10 to some number here. All right, that's the general form that scientific notation takes on. Now, thinking about this here, trying to make a sense of scientific notation, if it's not something that you're familiar with, might be kind of hard, but just as a couple general rules, I've got these three things here. So, if that number in the exponent is positive, if we've got a positive exponent of 10 here, we're talking about a number there that's generally pretty large. All right, so keep that in mind. That's what that would indicate. If that number there, the exponent on the 10, is negative, then we're going to be talking about a number that's relatively small. All right, and then the number itself just tells you how many places over you're moving the decimal when we convert it from standard to scientific to standard notation. All right, so again, biggest things here. If this is large, then it's a big number. If that one's positive, it's a big number. If that is negative, then it's a small number, and then we just move the decimal places over how many times we need to based on what that says there. So going over here to the main page, we look at number 1. This looks like it's a small number. It's a decimal, okay? So we know right now that when we get done with this, it's going to have a negative exponent on that 10 because it's a small number. Then what we have to figure out is how many places we're going to move over the decimal place. So we start here where the decimal is, and we bump it over 1, 2, 3, 4, 5 spots, okay? And now we have one non-zero number on the left of the decimal place, and that's where we stop. So it ends up being 3.3, and it's a small number, so it's going to be negative, and we moved it over 5 spots, so it's times 10 to the negative 5. All right, this next one, 50,000. That's a large number, so in the end, our exponent is going to be positive. To get this so that there's just one non-zero right on the right of the number, we're going to bump it over 1, 2, 3, 4. And we've got that one non-zero right on the left of the number I meant, okay? So 5.0, all right. We moved it over 4 spots. We had a big number originally, so that's going to be positive. 50,000 is a pretty big number, so that's going to have a positive exponent on the 10. Next one here. To get just one non-zero on the left of the decimal point, we're going to go 1, 2, 3, 4, 5, 6 spots over there. We end up with 2 or 2.0 you can write. Either, if you wanted to leave off the 0.0 there and just leave it with 2, that's actually technically acceptable too. But I think it looks more standard if we write it this way. So 2.0, it's moved over 6 places, and this is a small number, so we know it's negative 6. All right, because 0.00002 is a really small number, so it should have a negative exponent there. Problem number 4. All right, this one doesn't have a decimal point in it explicitly, but any number without a decimal point, it's always hiding right here at the end of the number. All right, so you can just add it in. We want to move this over, so there's just one non-zero on the left of the decimal place, so we bump it over 1, 2, 3, 4, 5 spots. All right, and that gives us 2.3 times 10, and then this one, we moved over 5 places, I said, and this is a big number, so we know that it's a positive 5. All right, because 230,000 is a big number, so we should have a positive exponent on the 10 there. 465, that's a pretty big number. Decimal point starts there. All right, we're going to move it over 1, 2 spots. All right, that gives us 4.65. times 10 to the, and because, as I said, this is a relatively large number here compared to, we're always comparing to 1, really. Okay, so it's a relatively large number. We moved it over 2 spots, so it's times 10 to the positive 2. This next one, really, really big number, all right? Decimal point, remember, if it's not written, it goes at the end, so it's right there. We're going to bump this over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 spots. All right, so we get 2.36 times 10, and it's going to be to the positive 11 since that was such a big number. All right, this next one we're dealing with very, very small number, okay? And so we have to count how many spots the decimal is going to be moved over here to get just one non-zero on the left. So we bump it over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 spots. All right, so this is 2.36 times 10 to the, and then it's going to be negative 13 because we moved it over 13 places, but it's a really, really small number, so it should have a negative exponent on that 10. Next one here, 48.95. This one is a relatively large number. Again, we're comparing to 1 here, so relatively large. We're going to bump it over here 1 spot, and so it ends up being 4.895. All right, times 10 to the, and we only moved it over 1 spot. So it's larger than 1, but it's only slightly larger than 1. So it's got a positive exponent, but it's a little tiny positive exponent. It's just a 1 there. All right, continuing on here, we're going the other way. So again, think about what this means. 3.7, all right, and this needs to be, since it says 10 to the 5th, we're looking at a big number here because that's a positive exponent on the 10. So if you're thinking about 3.7, and we need to move the decimal point one way or the other, and we're trying to make it into a large number because the 5 was a positive on that 10, okay, we can either move it this way, all right, but then we're ending up with things like 0.0037, all right, which would be small. So that's the wrong way to move it, all right. So what we'll do here is, again, start with 3.7, all right, and as we move the decimal this way, the number's getting bigger and bigger. 1, 2, 3, 4, 5 spots over we need to move the decimal. Now, what we have here is a bunch of empty places. Sometimes I like to call those egg baskets. All right, egg baskets because we need to fill the empty places in with these placeholders or these little eggs, 0, 0, 0, 0. All right, and what we end up with there is 370,000. For problem number 10, it's times 10 to the negative 4th, so we know that this is going to be a small number when we get to the end. 3.21. We're moving it over 4 places. We want it to be a small number in the end, so we're going this way. 1, 2, 3, 4. Fill in the empty spots. There's 1, 2, 3 there. All right, and so we end up with 0. I put another 0 in front of the decimal point just because it's a little bit more proper. So there's that 0 there, and then we got 3 more zeros. 0, 0, 0, 3, 2, 1. 6 times 10 to the 5th. All right, so we start here with 6. Decimal point, if it's not shown, is right here at the end. All right, we're going to move this over 5 spots. It's a positive exponent, so we need to make it large, so we're going to move it over this way. 1, 2, 3, 4, 5. All right, decimal ends up here. We have to fill in these with placeholder zeros or eggs. 1, 2, 3, 4, 5. All right, and then we have 600,000 here. All right, 1.99 times 10 to the negative 3rd. 1.99. We're going to be making this into a small number, so we're going to be bumping over this way, the decimal point 1, 2, 3. All right. Placeholder, placeholder. That 1 is occupying that other space, so we don't need another 0, so just 2 zeros here. And then I put, again, another 0 in front of the decimal point just because it's a little bit more scientifically proper. So 0 point and then 0, 0, 1, 9, 9. Next one, 1.7 times 10 to the 12th. This is a really big number because it's got a positive exponent and that's a really big positive exponent. So we say 1.7. We want to make this into a big number, so we're jumping over 12 spots. We're going to be jumping over to the right. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, and it ends up there. All right. We have 11 zeros there total, so 17 and then 11 zeros. Sometimes it helps if it gets long like this to add in commas just to make sure you got it right. So there's a comma there, comma there, comma there, comma there. All right, that looks good. We got 11 zeros. All right, 8.653 times 10 to the negative 17th. All right, so we're moving this decimal place over 17 places, and it's in the negative direction. So I'm going to give myself some room here. We get 8.653. All right, and then I'm going to move it over 17 spots. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 spots right there. Now we need to fill this in with a whole bunch of zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 zeros we end up having there in the end. All right, so now to copy this over, again, I'll put this 1 0 in front of the decimal point just for proper scientific writing here, but then we have 16 after the decimal point, so 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to get rid of this number just to give me some more room. 10, 11, 12, 13, 14, 15, 16, and then we have our 8, 6, 5, 3. For these math problems, I'm going to recommend that you do them in your calculator. So I'm going to give you a little brief tutorial on how that will work. But other than that, I think really that would be best if you just came in and saw me if you're having trouble using your calculator. But make sure that you're putting these in and getting them right. So I'll go through and do the first couple and tell you how I would put them in the calculator. But other than that, if you're having trouble getting things calculated right, you should just come in and see me. All right, so what I'd say is the first thing with these is there's some strange order of operation things that happen when you put them in your calculator. So you got to be careful about that. I use something that's called the EE key or the exponent key. This is what it looks like. All right, if I have this first one, instead of writing 2.3 times 10 to the third, I can write 2.3 E3. Now, what that E stands for is it stands for times 10 to the, okay, so 2.3 times 10 to the third is how that reads. And what's nice about this is it keeps everything smaller, it's actually less buttons that you have to hit, and then it actually throws a little set of parentheses around this in your calculator, so it knows to keep that whole term together. This is important for order of operations, especially when you're dividing by things with scientific notation. So whenever we do scientific notation in this class, I recommend you use the E button on your calculator and make sure that, you know, if you want to see how to do that, you come in and talk to me. All right, so we start with 2.3 E3, and we're going to multiply it times, so you hit the times button in your calculator. All right, and we're going to multiply that by 4.0 E5. All right, and then you'd hit equals. And my calculator spits out something really big. All right, it spits out 9, 2, and then it's 7 zeros. All right, so you can write that down as an answer, or because you're especially savvy now with scientific notation, you could just write 9.2 times 10 to the 8th. Either one of those would be acceptable. So I'm going to go through and just write down the answers to these next problems until we get to division, because division is where you really, really need to double check yourself. All right, so those are done, and now we're going to move on to the division problems here at the bottom. Problem number 19. Again, I'd put this in my calculator this way. 6.7 E2, all right, times 10 to the second is what that stands for. All right, divided by, and then 1.3 E3. You'll notice if you just put it in your calculator without the E button, you said 6.7 times 10 squared divided by 1.3 times 10 to the third, you'd actually end up getting a different answer than what I'm going to get here. and that answer that you would get would be incorrect. And it's a weird order of operation thing. So unless you use parentheses, which it's hard to have to remember, and it's way more buttons, you know, it's way better just to use this EE key. And what I get out of my calculator is 0.515. So that's how that one works. Again, on number 20, we're going to say 8.1 E4 divided by 9.0 E negative 3. And for that, we get 9 million. For one like 23 over here on the right, it's the same general concept. So what you've got to do is just put 8.64 E negative 8, because that's the times 10 to the negative 8, plus, all right, 2.4 E negative 4. When I do that, my calculator spits out 0.000240086. All right. I'm just going to go through and fill in the answers for the rest of these. Again, mostly this is just practice putting it in your calculator. If you need any additional guidance on this, please come in and ask. And there are the final answers on those. So again, if you have any problems, make sure you come in and talk to me.